So I want to say this is calculus. Everybody? Everybody? Right? Okay. I hope you're all familiar with Canvas. Canvas is where you will find my syllabus. You should look it over. Please check the dates for the midterm and the final. Please don't come to me in 2 months and say, oh, this birthday party I have to go to in Alaska. Please. There are valid excuses if you're sick. You're on the golf team. It happened last semester. But please check that out and let me know if there's an issue. Things to know. This isn't even the up-to-date one. I guess since I'm on my own, I can just free associate here. How many of you have taken calculus before by a show of hands? Okay, some of you have not taken calculus. How many of you did not take a math class in year? Okay. Yeah, okay. How many of you were top-notch A+ students your entire high school career? No, you don't have to raise your hand. Okay. This is going to be a hard course. It's the next math course. It relies on everything that you've already forgotten from your math classes. Trust me, just about everything. And today I'm going to do a review because I learned that that would be a good idea. Now, you will not, some of this, hopefully all of it you'll find like, oh, I remember that, that's boring. Get on with it. Hopefully, that would be a good sign. If there's something I go over and you're like, oh man, I don't remember that, you will find in the Stewart, in the first chapter, there's no calculus. It's just kind of a review. And you would be best to go over that. Somewhere, page XX, V, etc. There's some diagnostic tests. If you're unsure, take the diagnostic, be honest with yourself, they give you answers, take the diagnostic test. See where you fit. If you find that you're a little behind, that doesn't mean you can't take this class and you can't pass it with flying colors. You're just going to have to work hard. Now, I'm one of your resources. I have office hours. Every Tuesday I'll be there after class. Thursday, if you want me there, I'll be there. And I can do Zoom sessions or make other arrangements if you need help, either with the calculus or the prerequisites. But don't let this slide, right? Don't let this slide, because if you do, you're going to find yourself in the middle of the semester panicking, and there's no way, there's no way panic is good. So, all right. So that's some general suggestions. I guess I should say some. I should go over this. You can read, what my grading policy is. You'll notice I don't give a lot of credit for homework. That doesn't mean it's not important. It's actually very important. Your homework is not going to be graded on correctness, right? There's no reason, to seek out answers on the internet or, do the homework, do your best. You will get full credit for it if you do it, sincerely. The purpose of the homework is to practice and to find out where your weaknesses are. I want to encourage all of you to come in after, with an assignment with questions if you have difficulty on some particular problem, right? They'll have time in class to go over. If you don't feel comfortable doing that, well, come to my office hours, or write me an email, or we'll do a Zoom session. But it's really important that when you're doing the homework, if you're like, oh, I don't know how to do this, that you find out, right? Most of the grade is going to be on the exam. Now, the exams, the 2 midterms and the final. Now, one thing you will find about my exams is there are very few gotcha questions. There are very few questions where you're going to mess up because there's a lot of ugly fractions. I always take the exams a couple times myself, and if I ever that looks a little too tricky, then I change it. So you're also going to find that my exams are not time stressful. You're going to have plenty of time, and insofar as if you work very slow and methodically, and you get to the end, and you're still working, and you need more time, then we'll arrange to have that. We can't use this room, we'll go down to my office and you can complete it. Mathematics is not a speed test. It never has been. Mathematicians who are professional PhDs don't sit there and go, I've got an hour to solve this proof. It doesn't work that way. So the main thing is you learn the strategies, you learn how to work things out. There's always a certain amount of trial and error. Well, some people are a little more intuitive and their first try is a little better. But you're not going to get penalized because of that. You just need to know the material. Okay, so that's my song and dance. I want to make a comment. Invariably, what shows up on my student reviews is 3 or 4 students say, he makes mistakes. Or something. No, not that way. Yes, I'm going to be up here on the board doing math, and occasionally I'll be making a mistake. I do not do it. I could program my lecture so it's just this boring recitation of everything. But I think it's a good idea that I leave my flaws here, because I want you to follow what I'm doing, right? I hope I don't bore you to the point where you can't, but you should follow. Is he doing the right steps? And if you see something wrong, raise your hand and say, hey, Mr. Shomron, I think you made a mistake, because I'll eventually find it, and then I'll waste some of your class time finding it. But that's normal. You're going to make mistakes too. And you need to know how to deal with that. You need to know how to see that you made a mistake, how to go back, when to start over, go from scratch. That's just part of math. It's normal. There are very few savants who just, whatever they write down is always 100%. So, okay, just a minor. All right. Okay, so I mentioned Canvas. You'll find the syllabus there. You will find assignments. I will post assignments there. Is anyone here just totally unfamiliar with Canvas? Is anyone here for the first semester at USF? Oh, okay. You might not be familiar with Canvas. It's pretty straightforward. Your first probably reference is your neighbor. Your next reference is me. And you can't find something. I assume everybody. I guess I should write down my email in case you just don't happen to have that handy. This will give you practice learning how to spell my last name. That brings up kind of a tricky subject here. I've been told that I am not allowed to post things anywhere but on campus. And there are some things that I won't post on campus. Nothing illegal about it, it's just I don't want to. I have my own website. Here's knowing how to spell my name comes in handy. There's a lot of stuff on there that has nothing to do with school. So if you want to skip that, you can just go to USF. And there you're going to find, I'm going to post my notes for class. The same notes that I don't have with me today. So you can like write down notes in class and compare them with those notes and see if have a good memory. You can see I'm also going to try and videotape classes. I'm going to try and videotape classes and post them on YouTube. Well, how do you find them? Well, I'll put the links up here. You will also find, I taught this class last semester, so even if I do miss a videotape of the class, there might be an older one you can look at. This would be really helpful if you miss a class, or if you fall asleep in class, or just want to go look it over. So, hello, how are you doing? Your name is Mike. Michael Leonard, right? And where did? So just because I want everyone to be aware, Michael, you can change your seat, but we want people to try and at least, try and choose a seat they like, so that we can do contact tracing if we really need to. All right. What else? This is a long class. I like to give people about a 5-minute break in the middle. I have a little timer here to tell me if I forget a few minutes that we've gone over. No. Yeah. Okay. Some class rules. Any of you who are misinformed, you're adults now, and I will treat you like adults. You don't have to raise your hand if you need to go and use the facilities, or if you need to leave early. If you use a cell phone, please put it on mute. I don't care if you need to communicate. It's not high school anymore. I think you all know that. What else is there? I'm sure there's something I can always mention it next class if I miss something important. Are there any questions? Issues? Stuff? Yes?
I do not have the textbook yet. Could you tell me anything about it?
I'm going to do a little adjustment here. You're in the back. Sorry. And you have a mask on. Okay, try again.
Have you mentioned the textbook yet?
I haven't mentioned the textbook. The textbook is Stewart. I think it's version 9. I've been asked in the past, do I care whether it's online, pages? No, it doesn't matter. You'll need it mostly because that's where the problems, homes are going to be. Since you brought it up, I'm going to mention this now. I'll probably mention it again. For any of you who have any kind of doubts about your background, the first few sections, 1.1, because I think it was 1.2 or 1.3, I didn't see any point to, but 1.3, 1.4, 1.5, some geometry, some algebra, some pre-calc. It would behoove you to look it over. We're going to go over some of the stuff in class today. Again, you know, you're going to need this background. If you're weak in it, you want to do what you can to get yourself up to speed. It's always okay to ask a question about something that might not be calculus. Like if I have some, and I write on here, I wonder what the roots are. Okay. And you say, what did you just do? Well, anybody here know what I just did? Yeah.
The quadratic thing.
Yeah. Everybody should know, we'll get to that. You should know the quadratic formula. You should know that this tells me the roots of this little equation. All right. No subject, no math subject anyway is off the table. All right. I guess I'll just say this. You will find in the syllabus, I've been told that's a bad idea, but I don't care. My phone number. It's an emergency. I can't imagine an emergency in math class. You can text me or call if necessary. I hope, everyone would use that judiciously. All right, one last try. Any just questions about anything that we've talked about here? Yes?
For the homework, if we have a question that we really stumped on and we come in, are we allowed to ask if you'll explain it?
Absolutely. Absolutely. And furthermore, I would encourage you, because in a class this size, probably 70% of the people are, I'll say, math shy. They'll have the same question, they don't want to ask it. So you ask it, you're helping yourself, them, helping everybody. Okay, so yes, I encourage that. I never really thought about it. I think maybe the beginning of class is probably a good time before we get started, because if I wait till the end, we'll never get there. Okay, so we're going to cover as best I can, without my notes, some geometry, some algebra. I'm going to divide these up because it depends on where you went to school whether you would divide these up. Some pre-calc and some trigonometry. I really want to get as much time in on trigonometry because that's the subject I found students, the difference between what they needed and what they knew last semester was the widest. Yes?
I just had a question. Which calculator do you prefer? Do you have graphing calculators or do you have scientific ones?
Okay, so technically, you're not required to have one. We will get to a section where you will need one. I have a bunch that I can loan people if you don't have one. If you have an iPhone, I don't know, I think probably Android, you can get a virtual calculator, but you can't use it on an exam. So again, maybe I can help you out, or if you own one, great, borrow one. The bottom line calculator is Texas Instrument 83. Any of the models above the 83, 84, 85, I think it's the 86 where I have to draw the line. There's a calculator that'll do things that we're trying to teach you. And I was teaching high school about a decade ago, and I had a student who had this fancy TI calculator. He took his final exam, and all the derivatives of trig functions were wrong. They were all off by a weird constant. I found that he didn't really learn how to do the work. He learned how to use the calculator, but he forgot to put it in gradient mode. Yeah, that's not good. Okay. You ever do that?
Yeah.
All right. Okay, so, okay, let me backtrack and say something about exams. I will not give an exam where you need a calculator. Some people have learned to rely on them to do simple math. You're allowed to have a calculator. You can have a lesser, just addition, multiplication calculator. You can have one of these. There are some problems where they will help later on. If not doing the problem, checking the problem, I encourage that. That's part of math, is checking your answers. So, yeah. All right. All right, let me just see where we are. Okay. Let's start with, this isn't going to take long. We talk about geometry. Most important thing in this class, it's going to come up, the Pythagorean Theorem. Even though I know it's been a while since most of you have taken geometry, you should all know a squared plus b squared equals c squared. What does that mean? I have a right triangle, I have two legs, A and B, I have a hypotenuse, C. Okay. There are a few right triangles that come up in problems a lot. This isn't so much curriculum, it's just good to know. The most common one is the 3, 4, 5 right triangle. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. It's always good to have that down. You should know what an equilateral triangle is. A triangle where all 3 sides are equal. And someone tell me the angle.
60.
Yeah, there's 3 60-degree angles. Now, that's pretty simple, but there's something I feel is important you can do with the equilateral triangle. You take your equilateral triangle, I didn't draw it very well, you drop a perpendicular. Okay, we can show that these 2 triangles are congruent. So if this side is 1, this side is a half, and since we have a right triangle here, anyone know what the third side is going to be?
It's the
I'm
square.
tempted to try and move next minute. Be a seat booster. There are other seats if you decide it's not going to work. But anyone? Yes.
Is it a square root?
It is a square root. Yes. Okay. Forget that I'm quizzing you, right? This comes up a lot. This triangle. All right. If you can figure out what I just told you, you can figure out the rest. You think of the Pythagorean Theorem. It's 1 squared is going to equal a half squared plus x squared. All right? Did I do that right? I think I made a mistake. No. 1 equals a quarter plus x squared. So x squared equals 3/4, or x equals square root of 3 over 2. It's nicer if the side is 2 and then this is 1 and this is square root of 3. There are all sorts of triangles that will come up that will be similar to this. That means their sides are in the same ratio. I'm not trying to teach you geometry here. Just warning you, this is going to show up in problems. Any physics people here? No, not physics people. They love to put using physics questions, you know, forces and vectors and everything. Okay. The other thing you're going to need from geometry is all those area, I guess we'll start with here, area and volume formulas. You know what that is? You hear that? Oh, okay. That was feedback. Okay, so the most basic thing is area of a rectangle, length and width. This is not a test of math, this is a test of shyness, showing you're not shy. What's the area of a rectangle? Somebody?
Length times the width.
Length times the width. Okay. Area of the triangle. So we have a height and a base.
Half the base times the height.
You have it's the same person. It's Michael, right?
No.
Yeah. I know you're not shy. Somebody else. What's the area of the triangle? Yes.
1/2 base times
1/2. Thank you. Okay. Area of a circle. Radius r. Yes?
Higher square.
Okay. These should all be like embedded, you know, burnt into your brain cells. Volume. I'm not an artist. Any art majors here? Maybe there should be.
Still, the line is the wrong way. It has to
Yeah,
be
I
the same way down.
Come on, math keeps you bad. There's a brick. Does anyone know what we call that? A brick shape?
A prism.
Prism's more general. Like you could have a like a hexagon, right? That would be a prism too. It's called a parallelepiped. And the volume, length, width, well, that's probably the height. That's probably the width. Doesn't really matter, does it? And the volume, of course, is, yes?
Length times width times height.
Okay. I know it's simple, but now you've graduated. You're no longer suspect of being too shy to ask a question. We have this thing called a pyramid, which could have various shapes of bases, triangles, squares, rectangles. Does anyone recall the volume of a pyramid that has a base of some area, base, and height? Anyone recall that? Ooh, it's been so long since geometry. Yeah, I have to warn you, Ariana. You're Ariana? No? Did I miss this? No, I'm sorry, Lisa.
That's me.
You're Lisa, you're, tell me your name?
Me?
Yeah.
Samantha?
Oh, no, I'm sorry, the woman in front of you next to Lisa.
Oh, Monster. Moms are up. Sorry, I know it's under the mask.
That's it. If you accidentally scratch your head, or do something like that while I ask a question, I'll assume you're answering, so watch out. Okay, volume of the pyramid? Uh-oh. It's 1/3 base times the area of the base. I'm sorry, height. 1/3 the height times the area of the base. That's good to know. Cylinder. Area height, h, radius r. You know the volume of the cylinder. Yes?
I'm just guessing it would be height times pi r squared.
It's the height times pi r squared. As a general idea here, you have a shape, in this case a circle, and you kind of move it, then it's just the area of that times the height. Eventually, in calculus, we're going to look at finding find volumes of very, very complicated objects, and we can actually use that idea later on. Okay, we're almost done here. A cone, radius r and height h. Yeah, I know, you know.
I'm guessing, man. I don't know it for sure.
Okay.
Half height times pi r squared.
Yeah.
Cool.
That's a good guess.
Thank
It's
you.
wrong, but it's a good guess. Anybody? No, better, hey, come on. This isn't, I'm sure everybody has this thing that, oh, I hate math because they have to get it exactly right. Close is not, well, it's not, how do you get to exactly right? You guess and check it out. Well, I don't know how to, I do know how you can check this out, but we're not going to do it.
Is it a fraction?
It's a fraction.
Times height.
Is it 1/3?
It's 1/3. Just like the pyramid. There's a interesting, might as well. So you got a pyramid, right? Well, let me do it a little differently. I got a triangle, which is 2-dimensional, and I take a point and then kind of reverse it. So now my volume is, no, I'm sorry, I'm gonna back up. I have a line, and I take a point off of it, and now I have a triangle. And the fraction I get is a half. Right, this is a 2-dimensional object. So now I have a triangle, and I take a point off of it. And now the fraction is a third. This is a 3-dimensional object. So if I wanted to be a math major, I'll take a cube. And now in the 4th dimension, I take a point and I connect all these vertices here, and I have a 4-dimensional object, a 4-dimensional volume. I think we could all guess now what the fraction we're going to need is, aren't we? It's going to be a 4. It's not a coincidence. It's not part of this curriculum. Okay. One more volume. I'm not going to torture you with surface areas yet. Volume of a sphere. Okay. Radius r. Anyone This is a hard one. All right, if we have this on an exam, I'll just put it together. It's 4/3 pi r, what do you think the exponent is?
Cube. Cube.
Cube, that's right. Yeah. Okay. All right, that's our geometry lesson. Yes?
Does the formula for a three-dimensional triangle change when you have square base instead of a triangle base?
Would it be 2/3?
That guy? It's still 1/3 times the area of the base. In fact, if you take any object like this, you know the area of the base, that weird kind of shape you get by squeezing it up to the point, it would be 1/3 times base. We almost will get to that in this class. If you take Calc 2, you can actually show that. All right. Let's just take a look. I think I learned no, 8 minutes. And then we'll take a break. So, first thing I want to talk about with algebra is, that's not the first thing. I want to talk about some simple stuff. And I'm only going to slow down when you raise your hand and say, wait a minute, because I know some of this is just so simple. So you might be familiar with a linear equation in one unknown. You better be able to solve that. Anybody do it in their head?
4. No.
-1.
-1.
I get -1. Yeah. But, it's a general rule. I mean, not for some, we won't see many of these. Okay, -1, -2. Oh, okay. It worked. It's a good idea whenever possible. Whenever it's easy, certainly check your work. Because we're human and make simple mistakes occasionally. Two equations and two unknowns. I hope this is second nature to you. How do we go about solving this? There's two ways we generally, well, I know 5 ways. There's 2 ways we normally do it, right? We use substitution, or we use elimination. Substitution, we solve for y and plug y into there and solve for x. Elimination, well, maybe we multiply this by -2, so we get -6x, and you add, and you just have y and y, and then you find the other. For those of you who love algebra, there's Kramer's rule, which has the nice feature that it'll work 2 equations and 2 unknowns, 3 equations and 3 unknowns, or any number. Oh yeah, we have a lot of, okay, that's right. Computer sci. There's computer sci here. Yeah, a lot of computer sci. Kramer's rule is just kind of an algorithm. So you could write a program, I mean, you know, without knowing a lot, well, you just have to know grammar school and how to work that. And you could do 10 by 10. Any econ majors in this class? Oh, econ, I'm just going to tell you, the more math you know, the better off you are. And you're going to call up the computer sci guys to write a program to do a 10 by 10, by, you know, solve your model for the economy and stuff like that. Okay, Cramer's rule. There's we can use Gaussian elimination, use matrices. That's not there. You know how to do this through later. Okay. All right, so out of breath. So excited. You need to know what a polynomial is. Polynomial. Well, you also have to know kind of the parts of a polynomial. So you notice there's a bunch of x's, those are our variables. This could be, I wrote p of x because I'm talking about polynomials, but typically we'll say f of x. We'll get to functions later when we need a function. But this is just an algebraic expression. The a's are constants. They're like a number, we just don't know what the number is, but it's just a number. X is just a variable, just like in our linear equation. Each of these items here that we add together is called a term. This is just kind of a vocabulary lesson, I hope. This is called the first term is called the leading term. I'm sorry, this term. The numbers in front, as I mentioned, they're called coefficients. Oh, I'm so bad at spelling. Two F's? I don't remember. And yeah, that was my bad subject. I sympathize with people who have a tough time in math, because I had a terrible time spelling and other things. The coefficient on the x with the biggest number is called the leading coefficient. And this final coefficient is called the constant term. Okay. And anyone know what the n here is called? The biggest number on an x, the biggest exponent?
Oh, is it the degree?
It's called the degree. N is the degree. Okay. Now, I kind of jumped ahead and was very, general here, because we're going to talk about different kinds of polynomials, and in particular polynomial equations. That's where you have some polynomial, we would make it equal to 0. You could make it a constant, but then you could just subtract that. You think you need a break for a few minutes? Okay. Be back in, do you know where the men's room is upstairs? Is there one?
I think there's one downstairs. I think it's, the women's bathroom on top and then the men's room on top, on the second floor.
I'm gonna have to run. I'll have to run. Okay, meet me back in 5 minutes. We'll do more algebra. So, one of the great things about having a break is you have time to stop and think. I remembered something I thought I should tell everyone that would make a lot of people very happy. On my exams, I have a policy where you can bring along a sheet of paper that you can write anything you want on, both sides, as small as you can read. So, I'm sorry. So, there's some formula, and you know the formula, and you need to use it, but you're a little afraid you're not going to memorize it, you're going to mess it up, and you get into the exam, and you're nervous. You didn't write this stuff down, and I'm telling you now because, you might want to accumulate information as we go along. You might want to, spend a day or two before an exam when you're preparing and writing up too, but it's an option. So, okay. All right.
Right. Do they have to be written or can they also be printed?
You can print it. Yes?
Are there any limits to what we can write on it, or we can put anything we want?
Poetry, advanced astrophysics. Good. Like, what could I, the answers that you got. Yeah. Okay, I guess I can switch modes for a second. Going back to the part about we're adults here, I'm uncomfortable because I'm not accusing anybody of anything. But I do know college students have a lot of pressure on them. And I understand, everybody's been tempted at one point in their life to do something they thought they realized they weren't supposed to do. My expectation is you're adults here, you understand that when you turn in your homework, it's not something you copy from someone. I encourage you to work together with them, but it's your own work. Same thing when we're doing an exam. We tight quarters here, but obviously, it's your stuff, not your neighbor's stuff. I just felt I had to say that. Again, if you get to the point where you feel like, that temptation is like overwhelming, we have counselors here. We have lots of help, right? I also understand from having taught here a few semesters that for some people calculus is not so much it doesn't seem like a necessary knowledge. It's more like a hurdle. I know I haven't said much about this. My career, for the most part, has been a computer professional. I started programming when I was in my 10th grade. We had a little computer. And you would laugh at, if I told you, how we programmed, on a teletype with paper at 300 baud, you would know what that means. But I haven't needed much calculus. I like it. I went back to school and got a degree in math, and I love it now. But I understand, the trade-off. But there's definitely, any technical subject you're dealing with here, you're able to persevere and learn all this. You can do pretty much anything. You can be an astrophysicist, if need be. So, or brain surgeon, I guess, you know, with dexterity. All right. Any questions come up since I left? Okay, I'm gonna apologize. Go hide behind here. It's getting a little warm. Okay, so this is kind of the general polynomial kind of thing. Things I would hope you already know are, I'm gonna write that up again. I have the numbers. The numbers instead. I have to make up some good numbers here. Okay, there we go. So there are a number of ways to solve this. If you're fortunate, there's a simple way. I would call it, you can call it whatever you want. There's reverse FOIL. That's what I'm used to calling it. Factor it. Go, well, there's an x there, there's an x there. Well, that's 4, 4, 1. Oh, good. Because the outer 4 and the inner 1 add up to 5. And now I know that the solutions are x equal minus 1, x equal minus 4. Some people do something, I think they draw a box. One of you is, I don't know how it works. Somebody here knows how this works? I don't want to know, I just, you haven't seen this? Maybe it's kind of out of fashion, I don't know. This doesn't always work. There's the catch-all quadratic formula. Okay, you could write that down on your sheet. It's good. This is good to know. This is really basic. Where A is, in this case, it's 1, B is 5, C is 4. We plug it in and you get those numbers out. This works for any quadratic or second degree polynomial equation. You should know that like the back of your hand. When we get past the quadratic, it's kind of a crapshoot involved. I unfortunately don't have a good example, but I'll make something up. Okay. So for something like this, there's kind of there's a way, you know, to try and get you through called the rational root theorem. Just curious, has anyone heard of the rational root? Okay, good. It's not good, it's the only one. The idea is, you look at the leading coefficient and the constant term, and you can factor them. 3 is 3 times 1. 1 is 1 times 1, oh, all right. And you can take all the combinations, which are, in this case, 3 over 1, 1 over 1, negative 3 over 1, negative 1 over 1, and you can try them. And if they work, great. If they don't work, none of them work, too bad. It isn't guaranteed, but in a lot of cases, let's just give this a try. 1 plus 2 plus 1, no, that didn't work. Negative 1 plus 2 is 1. No, it didn't work. I'm not going to try 3. So there's the rational root theorem, and well, maybe let's kind of jimmy this here a little here. So 1 plus 2 plus 1 minus 4. Okay, so now 1 is one of the roots. So what do you do with this? Well, you can reduce it if you know